Welcome back, my AP Calc champions. In this problem, we're going to be talking about milk. This problem says a bottle of milk is taken out of a refrigerator and placed in a pan of hot water to be warmed. The increasing function m models the temperature of the milk at time t, where m of t is measured in degrees Celsius and t is the number of minutes since the bottle was placed in the pan. M satisfies the differential equation d of m over d of t, which is equal to 1/4 times 40 minus m. At time t equals 0, the temperature of the milk is 5 degrees Celsius. It can be shown that m of t is less than 40 for all values of t. Part A says, a slope field for the differential equation is shown. Sketch the solution curve through the point 0, 5. All right, cool. So with these slope field problems, I think they're really only worth like a point or two. So you want to make sure that you're sketching your solution curve through that point. So make sure that you start there. And another thing to keep in mind is it says m of t is less than 40 for all values of t. So where you can see that the slope field kind of bottoms out, where there's an asymptote, that's where your solution curve should approach, but it should not touch. And make sure that you don't sketch anything above that 40, because the problem has told us that it's going to be less than 40 for all values of t. Okay, so don't get caught up in the fact that there is a slope field above the asymptote. You don't want to get above it. Okay, so you're basically just going to be following the slopes, something like that. These slope field problems, as long as you get them pretty close to what the solution looks like, they'll give you that 1 point. So this is what I would say is the answer for part A. Moving on to part B, we're being told to use a line tangent to the graph of m at t equals 0 to approximate m of 2, the temperature of the milk at time t equals 2. So I've copied down our dm over dt. We're basically, so we have at time t equals 0, we know that the temperature of the milk is going to be 5 degrees Celsius. So what we're trying to do is we're trying to use that line tangent there to figure out what the temperature of the milk is going to be at time t equals 2. Okay, so what this means is we need to write an equation using the tangent line at t equals 0. So remember our point slope form, we have y minus y1 is equal to m times x minus x1. Okay, where y1 and x1 are points on that line. Okay, and the m is the slope. First, let's figure out our slope. How are we going to figure out our slope? We're going to use dm over dt. So if we're trying to find it at t equals 0, we know that m is equal to 5 at t equals 0. So we can go ahead and just plug that into dm over dt. So 1/4 times 40 minus 5 is going to be our slope. So that's going to be 35 over 4 for our slope. Okay, so we can go ahead and plug that in. So let me erase some of this stuff. So our slope is going to be 35 over 4. And now we need to plug in a point that's going to be on that line. Well, we can go ahead and use the point 0, 5, where this is our time and this is our degrees Celsius, or our m. So where we see x1, that's really just going to be our 0. That's our x point, or the t point if you want. And then when we have our y1, that's going to be our 5, or our degrees Celsius. Okay, and if you wanted to make this exact, you could convert this x to a t. You know, it doesn't matter too much. We're solving for a temperature, so which variables you're using, I don't know. I don't think it matters too much. So we have our equation set up here, so let's go ahead and simplify it just a little bit. So we have y is equal to 35/4 times t, and then since we would be multiplying 35 over 4 times each of the values inside of our parentheses. Since this is a 0, this just goes away, and then we can go ahead and add 5 to the other side. So this is what we get. We get y is equal to 35 over 4 times t plus 5. Make my t a little bit different than the plus. And then if you wanted to, you could, substitute the y for an m. Once again, the variables do not really matter too much. So we have an equation that's set up to solve for m. So now what we can do is we can just plug in 2 as our t. So we're going to get that m of 2 is equal to 35 over 4 times 2 plus 5. Let's see if we can go ahead and simplify this a little bit. So this becomes a 2, so we get 35 over 2 plus 5. We can rewrite 5 as 10 over 2, so we can get that this is 45 over 2. So that would be our answer for part B, 45 over 2 degrees Celsius. Moving on to the next problem, we're being told to write an expression for the second derivative in terms of m, and then use that to determine whether the approximation from part B is an underestimate or an overestimate for the actual value of m of 2. Give the reason for your answer. So I've once again copied down our dm over dt, and this time we're being asked to take the derivative of that. Okay, so I think it helps if you distribute the 1/4 across, so you multiply it by both of these. So we get 1/4 times 40 minus 1/4 times m. So we're going to get that this is 10 minus 1/4 m. So when we take the derivative of this 10 is just going to go away. It's just a constant, the derivative of a constant. It doesn't matter. We don't care about that anymore. So then we end up with minus 1/4 dm over dt. Remember, we're taking the derivative of this with respect to dt. So this m is not just going to go away. We're going to have dm over dt when we take the derivative of m. So now you might be like, oh, well, what am I supposed to do with this? This didn't really give me any information. Remember that we have dm over dt in terms of just m. So we can go ahead and actually just substitute this in for dm over dt. So we get minus 1/4 times 1/4 times 40 minus m. Then we can go ahead and distribute again. So minus 1/16 times 40 minus m is going to be the final form for our second derivative. Believe it or not, but this is actually enough information for you to answer the question of whether part B was an underestimate or an overestimate. The reason why is, so remember that m was going to be, let's scroll back up to the beginning of the problem. Remember that m was going to be less than 40 for all values of t. So what that means for us with problem C is that m is always going to be less than 40. So this whole expression here will never be negative, and it will never be 0. It'll always be at least greater than 0. So since we're multiplying a negative times something that's always going to be a positive, our second derivative is always going to be negative. Okay, so let's go ahead and write that out. Because m of t is less than 40 for all t, the second derivative is going to be less than 0 for all t. So then what does that mean? What does a negative second derivative mean? It means that our graph is concave down, okay? It's concave down, which means that if we looked at the tangent line for that, we would see that it's actually an over approximation, right? So let's say, for example, we were trying to approximate this value here. Well, on the tangent line, it's way up here, right? So the opposite would have been true if our second derivative was always positive. That would mean we would have a concave up, we would have that smiley. And what that means is if you took the tangent line of it, it would be an underestimate. So see where, for example, if we were trying to estimate this point on the graph, it's actually down here on the tangent line. So because it's going to be less than 0 for all t, the approximation in part B is an overestimate. The graph is concave down. Moving on to the next problem, we're being told to use the separation of variables to find an expression for m of t. The particular solution to the differential equation dm over dt is equal to 1/4 times 40 minus m with initial condition m of 0 is equal to 5. Okay, separation of variables. So the name is pretty straightforward. We're separating any variables that have an m on one side, and we're separating any variables that have a t on the other side. Okay, so right now we have a dm on this side and an m on that side, so we're going to want to fix that up a little bit. So what we can do is we can take our expression, so dm over dt is equal to 1/4 40 minus m. So what we can do is we can multiply the right side of our equation by dt, so we get dm is equal to 1/4 40 minus m dt. Then we can divide both sides by 40 minus m, so we get dm over 40 minus m. 40 minus m is equal to 1/4 dt. And I would say that we have successfully isolated all the m variables on one side, on the t variables on the other side. You'll notice we don't actually have like a t anywhere within our equation. That's okay. Remember that we're going to be taking the integral really soon, so just because there isn't a t doesn't mean that there won't be one in the future. Okay, so we have this in terms of dm and dt. We want this in terms of m and t. So what we're going to do is we're going to take the integral of both sides. So we take the integral of that and the integral of this. So maybe you're not familiar with what the integral of dm over 40 minus m is. So we can go ahead and we can use u substitution here. So we would say that u is equal to 40 minus m and du is equal to minus dm. Okay, so then when we go ahead and we substitute stuff, we would see that we have a minus 1 up top, and then we have a u up bottom. So we can move our negative out front like this. And then maybe this looks a little bit more familiar to one of those forms that you have taken the integral of. So remember that the integral of 1 over u is ln of u. Yeah, we can go ahead and do the same thing here and then use u substitution. And once again, this is still equal to integral of 1/4 dt. So with u substitution, we're going to get that this is minus ln of u is equal to the integral of 1/4 dt. We have this in terms of u. We don't want it in terms of u. We want it in terms of m. So we can go ahead and substitute our u for what we set it equal to, which is 40 minus m. So we get this. We have successfully integrated the left side. Now we need to integrate the right side. So this should be a little bit more simple, where we are just going to, the integral of 1/4 dt is just going to be 1/4 t, and then we have to tack on the constant of integration. We have it in terms of m and t technically, but we still have this pesky little constant that we need to solve for. So we can go ahead, remember the initial condition is m of 0 is equal to 5. So what that means is t is equal to 0 and m is equal to 5. And we can go ahead and plug that in to our equation right now. So we get minus ln 40 minus 5 is equal to 1/4 times 0 plus c. So this 1/4 times 0 should just go away. We get that minus ln of, we can just go ahead and subtract it, minus ln of 35 is equal to c. So now we can go ahead and plug that back in to our equation. And now what we want is we actually just want to solve for m equals. We have all this random stuff on the left side. We have an ln, we have that 40. We just want it in terms of m equals and all the other variables and numbers on the right side of the equation. Okay, so minus ln 40 minus m is equal to 1/4 t minus ln 35, right? Remember we solved for our constant. So now let's go ahead and simplify our left side such that it just looks like m equals. So we have this minus out front. So let's go ahead and divide by minus 1 by both sides. So we get rid of the minus on the left side. This becomes a minus 1/4 t, and this becomes plus ln 35. Then we still have everything in terms of ln on the left side. So to solve that, we can take everything to the power of e. Okay, so what this ends up happening is using this ln property, these are going to cancel out. So on our left side, we just have 40 minus m, and then on the right side, we have something a little bit more complicated. There's another property where we can just drop that 35 out front. So let's go ahead and rewrite this. So we have 40 minus m is equal to 35 to the e minus 1/4 t. Right? We're so close. We're so close. We still have 40 minus m. We just want m. So we can go ahead and add m to both sides. So we get 40 is equal to 35 e to the negative 1/4 t plus m. And now we just need to subtract this hunk of stuff to get just m on one side. So 40 minus 35 e to the negative 1/4 t is equal to m. Wow. We have done the impossible. We've gone through all of those steps, and we have finally solved for what our m is. And that is the answer here. 40 minus 35 times e to the negative 1/4 t is equal to m. Hopefully that helps you out with this AP Calculus problem. If you have any questions, feel free to leave them down below and I'll get back to you. And I hope you have a great rest of your day.